Dear students, today we are going to study about continuity and differentiability, exercise 5.1, and at first we will discuss about the continuity. After completing this continuity, we will go to differentiability. So what is continuity? In continuity, some functions are continuous and function fx, we denote this function is fx. So see the definition of function fx is said to be continuous at point x is equal to a if limit x tends to a negative a minus fx equal to limit x tends to a positive fx is equal to if. And what are these? To be continuous any function, three conditions should be fulfilled, then we can say any function is continuous. And what are these three? First of all, we see the graph. Graphically, how to say any function is continuous? Suppose here x-axis is given and y-axis means fx, y is equal to fx, we say y are fx. So we had made here one graph like this. It is the a, this distance a. So here the graph is completing without lifting the plane. If we draw the graph without lifting the plane, we can say any graph is continuous. Like suppose my first graph is here, second is from here, third is from here. So you see here, these graphs, if I plot the graph, pen is coming here, again we cannot continue here and lift the pen, we start from here, then from here. So if we lift the pen, this cannot be continuous, this will be discontinuous because that is the broken. ये जो लाइन चल रही है, कर्व है ब्रोकन हो गया, जहां ब्रोकन होगा उसको बोलेंगे ये डिसकंटिन्यू हो गया. नाम से क्लियर है, कंटिन्यूअस मींस कोई चीज कंटिन्यू चल रहा है, कंटिन्यू. So it is the continuous, and this point A is said to be continuity at point A. So graphically we can say it is the continuous, it is not continuous, so we can say discontinuous. Now see, our function fx is said to be continuous at point x is equal to a. This function is continuous at the point x is equal to a. And what is this thing? Three things. If any function is given, first we take left hand limit. You have studied in class 11 about limits. Left hand limit. Left hand limit. Left hand limit means it is approaches from left side. From left side. So we can say, so it is negative because from 0, this side, left side, numbers are negative. So x tends to a negative fx, this function. किसके इक्वल होना चाहिए? लिमिट x tends to be, it is tends to approaches to be a plus means after the 0 that side. So here left limit and there right hand limit. We say for right we denote a plus fx is equal to fv. Three conditions must be fulfilled to any continuous function. So left hand limit, how to find? It was in class 11, but now see here. LHL, left hand limit. Function is given, limit x tends to a negative fx. That means it is left hand limit equal to this x tends to a negative, it changes to h. H tends to 0. Now see here, h tends to 0 because it is approaches to 0, not equal to 0, only tends, approaches 0 के तरफ बढ़ रहा है. H tends to 0 and f here fx. Now see here fx, it is a negative, that means left side a minus h, it becomes a minus h. Here h, it becomes h minus a minus h. So it is the left hand limit. Like the same right hand limit, if you go right side, so we write right hand limit x tends to a positive fx. And how to this find right hand limit? So this a positive, it also becomes h tends to 0, but it is a plus, due to that it becomes a plus h. So in the right hand limit it is positive. because all numbers from 0 to right side they are positive. And so three condition to for the continuous, it is necessary to fulfill three conditions. Now next is discontinuous function. Just I told you discontinuous, मैंने इस कर्व को बनाया, यहाँ से यहाँ तक पहुंचा, फिर यही छोड़ दिया, फिर पेन को उठाया, फिर ये डिसकंटिन्यू हो गया, और दिस पॉइंट जहां ब्रेक हो गया उसी को बोलेंगे पॉइंट ऑफ कंटिन्यूटी. दैट मींस अ फंक्शन fx इज discontinuous at point x is equal to a if limit x tends to a fx doesn't exist. What it does exist means, suppose we have any limit x tends to 3 here and 2x by x minus 3, it is x tends to a. So what is the point of continuity at point x is equal to 3? If we put here x is equal to 3, if we put x is equal to 3 here, 3 minus 3 is 0, that means not defined, it becomes infinity. That time it coming infinity, denominator should not be 0, so that time you can say limit doesn't exist. So it was the first condition to discontinuity. Now number second, for the discontinuity, left hand limit not equal to right hand limit, that means limit x tends to a negative fx not equal to limit x tends to a positive this function fx. In this case also, left hand limit and right hand limit is not equal to, they are not equal to, not equal, that means they are different. In that case we can say function is discontinuous. And number 3 is limit x tends to a. In some cases 2 may be equal, right hand limit and left hand limit and right hand limit may be equal to 0. In that case, we both are same equal but not equal to fa. In that case, we can say these functions are not continuous. That means we can say that is discontinuous function. So we will do some questions from the exercise, so it will be more clear to you. Now you see that question number 1 is prove that the function fx is equal to 5x minus 3 is continuous at 3 points. X is equal to 0, x is equal to minus 3 and x is equal to 5. And to be the continuity for the function, any function is continuous, 3 conditions just we studied. Left hand limit equal to right hand limit and equal to f function of a. So if 3 conditions are fulfilled here, we can say that it is the continuous function. Now given function is fx is equal to 5x minus 3, and before doing this, first check this which type of this function. It is linear polynomial. Linear means power is highest power, that means degree is 1. Linear polynomial always continuous function, because if you draw the graph y is equal to 5x minus 3, so we can see here straight line. One straight line is we should get. So it is the continue at each and every point. It is continue. X is equal to 0, x minus 3. At each and every point, this function is continuous. Now at x is equal to 0, what becomes function? F x is equal to 0. That means x is putting 0. F 0 equal to 5 into x is 0 minus 3. That means 5 0 0 minus 3 becoming minus 3. And it is for the case of linear it is always continuous, so no need to find both this left hand limit and right hand limit. Only you can find only limit. Limit को केवल निकालने का like limit x tends to 0 fx equal to this f, it becomes 0, and this 5x minus 3, 5 into x is 0 minus 3, so this also becomes minus 3. Limit x tends to 0, also getting that this function also minus 3, fx is equal to, and that means limit x tends to 0 fx equal to this f0. That means this condition fa is 0 and limit fx both are minus 3. That means function is continuous at the point x is equal to 0. So it is answer for this x is equal to 0. So this function was continuous at x is equal to 0. Now next is x is equal to 3 and x is equal to minus 3. First we see our function is 5x minus 3, so we find function is 5x minus 3 and we need to be make continuous at x is equal to minus 3. So f minus 3 is equal to 5 into minus 3 minus 3. That means 5 3 is 15. In the place of x putting minus 3. 5 3 minus 15 minus 3 18. Minus 18 is coming. F minus 3. Then we find limit. Limit x tends to 0 fx. X tends to, it is minus 3 and here 5x minus 3. This is equal to limit x tends to minus 3, 5x minus 3 equal to 5 into x is minus 3 and this minus 3 minus 15 minus 3 18. So what we are getting here, limit x tends to minus 3 fx is equal to this f minus 3. This is equal to it is fa. That means the function is continuous at the point x is equal to minus 3. It was for x is equal to minus 3. Now next, for this x is equal to 5. X is equal to 5. At x is equal to 5. Then f 5 equal to 5 into x is 5 minus 3. 5 5 is 25 minus 3 is equal to 22. Now limit x tends to 5 and it is fx is equal to limit x tends to 5 function was 5x minus 3. This equal to 5 into x is 5 minus 3. 5 5 25 minus 3 is equal to 22. So you see here both are equal, that means therefore limit x tends to 5 this fx equal to f5, both are 22. That means function is continuous at x is equal to 5. That is